The ICEVI, the Nippon Foundation Mathematics Package for Teachers video series, Abacus as a Mathematical Tool. Title of the video, Square Root of Multiple Digit Numbers. Example, 103,041. Let us set the number 103041 by leaving 3 columns in the right side of the abacus. That is, the lowest digit 1 of the number should be set in the thousands column, 4 in the 10,000s column, and the remaining numbers in the subsequent columns. We had mentioned that for calculating the square root, we have to group the numbers from the right side. Therefore, 41 is one group, 30 is another group, and 10 is another group. For the purpose of calculation, we consider the groups in order as 10, 30, and 41. Take the first group 10 and consider the perfect squares there. 4 and 9 are the perfect squares in 10. Among these two, 9 is the highest perfect square, and therefore take the square root 3. Set 3 to the immediate left of 10 and subtract 9 from 10. Now you are left with 13,041. In the next stage, double the number 3 and set 6 in the extreme left of the abacus. From now onwards, you can mostly apply the division procedures. Consider 13 of the 130 and ask how many 6s in 13. You get your answer as 2. In the case of small numbers, you need not have to go for an assumed quotient. Here, you are clear that there are 262s in 130. Therefore, straight away set the number 2 to the right of the first digit of the square root and to the right of the number 6, which is set in the extreme left of the abacus. In the case of big numbers like 9, 8, etc., when you get that in the division process, you are expected to reduce 1 always and consider that as the assumed quotient. In the case of small numbers, you can set the quotient directly. Now multiply 2 with 62 and subtract 124 from 130 and you will get 6 as the remainder here, and therefore you are left with 641 in the abacus. Look at the square root now. In this problem, you are going for a third digit in the square root. In every stage of division process, we have to double the square root before going for subsequent calculations. In the case of double digit square root, we simply add one additional step, whereas in the case of 3-digit square root, we involve 2 additional steps. In every step, we have to take twice the value of the square root before getting into the next level calculation. In the square root section, we have 32. That should be doubled, and therefore the 62 becomes 64. That should be set in the extreme left of the abacus. Now consider 64 and 641. Look at the first digit of the dividend and the divisor. Here also you get small numbers. Ask how many 6s in 6 by saying 1. Set that 1 to the right of the square root And to the right of the number 64, multiply 1 with 641 and subtract it from 641. You don't have any remainder, and therefore your answer 321 is the square root of the number 103,041.